Right, okay, so let's get some things going. Cool, so what we did is this is like the third stream we're doing on this, and what we've been doing is this book, Thinking with Types, and I just linked it, and it's really cool. It's potentially a little bit complex. I mean, I still get thrown. I think it's like my second time, well, maybe third time through these various chapters. And the last one was on, I think, well, we did the first one was cardinality, and then or was this one the cardinality? Promotion of built-in types. Was that just the name of it? I think it was terms. There we go. So it's terms, types, and kinds. So we kind of explained things. This one was fairly, I think it was, we had a few little examples where we tried things out, but it's quite, oh no, there's a few more examples I explained. So basically, the essence of what it's showing is you can also think of types like functions, really. You can have, it's not as flexible as, your actual functions, but once you start messing with things like type families, etc., you can start thinking of types as another form of function. And then where it demonstrated that was, what chapter am I in here? 1. Where cardinality came into question, which was the first chapter. I'm going to put these up on YouTube. I haven't done these one yet. I've been trying to do a backlog of the other ones because I think Twitch gets rid of the historic one, just goes see you later. And then what I've been doing, I've been splitting them up and doing which every sort of what would you call it? Subject, that's a better word. Every subject I've been splitting up into different playlist. Yeah, so you can kind of follow them along. But I haven't started this playlist yet, so I'll put them up soon. Anyway, cardinality was stating that when we look at something like this, so this being, let's have a look further up. Does it give you the very first ones? Yeah, so you can see this spin up and down, which is, so it's basically a sum type. And then you might have wondered at some point, well, why is it called a sum type? It's like, what do you mean sum type? Well, the idea is if you use something called cardinality, I called it Cardi, or Cardi B if you're into your hip hop. In essence, it means that is fulfilled. So it's you can't get anything else than up, and you can't get anything else than down. So that's a cardinality of 1, and that's a cardinality of 1. So spin has a cardinality of 2. Okay, and then anything that's of multiple of the same cardinality. So we did spin and bool, because bool is exactly the same. Bool's got true or false there, or false or true, whichever one, and it's got the same. They can mix with each other. Okay, so then you're thinking, right, so why is it a sum type? But then it came up when we started looking at either, why things become sum types. So either A or B, then explain that A is whatever type that is and whatever cardinality that is, plus the B, and that's how you work out the cardinality of either A, B. It's dependent on what types you pass it. And then the next one was demonstrating that things like pairs. So then we moved on. So we kind of split we worked out what the cardinality of deal might be. So if you look at deal, it's expecting 2 values. It puts them on this, that, A and B, and the other bool. So we know that straight away, we know that bool's 2, and then we've got A and B. And then it says A plus B plus bool plus 2. Okay, so it's dependent. And I'm trying to show, and then we did it with this one, which is a tuple, and then in tuples they become product types. So that showed tuples, and then these also become product types, which is similar because this is it's to do with or and. That's how it's worked out. So we kind of went through that. I mean, it's probably best watching it again, and then we sort of demonstrated how we can use it in a simple tic-tac-toe game. And what it was is we have an empty board here, which involves there's 9 pieces, and it involves having 9 nothings to get them started. If we say the tic-tac-toe of A is a maybe bool, so if we say tic-tac-toe is a maybe bool, all of these are maybe bools. And obviously if you want to start a blank one, they'd all be nothings. So we have to do nothing 9 times. And then, but there's an alternate way of doing it, because if you start thinking about this, essentially, where does it say? We can split it up, because this turns out to be 9, the number being 9. And then you can do a new data type, which is called 3, and it's just got 1, 2, 3. So that's got the cardinality of 3. And then we explained that a polymorphism, which is like from one function to another. So if we add from a type 3 to a type 3, that's actually 3 times 3. Yeah, at a type level, that actually means 3 times 3 gives us an A. So what that meant is that's 9, which is totally reflecting to that. And then to create a tic-tac, and I think the idea was it'd split it between the rows. So it'd be row 1, row 2, row 3. And then you can essentially do this by doing const, and a nothing. And then that passes it all on to the function, because these are functions. That passes it all on. And that'll give you exactly the same result as doing this. Yeah, so maybe I'll go into, I spend like 2 hours on this. So I'm giving like a 2-second overview. And then we did chapter 2. Let's shut that. And this was what I was looking at before, types and terms. Yeah, and we kind of did an or and a not. And then we did a map, but we discovered we couldn't really do a map. You can do it, but it doesn't become useful. And then what these were key for looking at Chi's is, we see up here we did some language extensions that allowed us to do this, so type families and data kinds. And what that allows us, if we were to create, did I comment it out? Yeah, I kind of, no. So it shows you that, this concept is saying that a maybe is of type to type, and either is of type to type to type, because of, it expects 2 values, so that's A and B, type, and then it returns us a type. But then if you were to have either int, and then it becomes a constraint because it's been fulfilled. And this is where you see constraint here. So if you look at things like show on its own is a type to constraint. So it's expecting a type. When you look at show, it's usually show A. So it's expecting a type, and it gives you a constraint. But if you give it a show int where it's fulfilled, then that becomes that's just a constraint. So I think the idea is making us realize that really in functions is almost like another set of in types there's another set where they become functions, and they deal with something called type and constraint. And in another, actually I should mention, this is what you might have seen before. You might have seen like star lying around in places, but it's going to be turned into definitely in the latest version type is available. But yes, I think everything's going to move over to just saying type. And then what that entails, so we go through that, and what it means is basically when you do a bool, just say like you have bool available, then you get, what were they called? I think I forgot what they're called. Something constraint. I forgot. Yeah, there we go. Not so good. But what they entail, I can explain what they do though. You get these available to you. You see how there's like a tick. So you get exactly the same representation of a normal. So if we look at, if we were to do like data bool, we know that it's going to be true or false, isn't it? That's sort of fairly obvious. And then what that gives us is an extension which is saying that bool tick is of the kind bool, and then true tick is of the kind is of a constructor. I think it's, hold on, I'm gonna have to look back. My brain's not that good. Here we go. So we can know it a bit further up. I think it's good to go over these things because I have forgotten. Exactly is. There we go. That was it. Promoted data constructors. You've got a better mind than me. Well done. And yeah, here we go. So this is the explanation. So you get a type constructor. So this is setting it up like this. I think it's, yeah, let me know if that's not big enough to read. So we get a data.bool, and then we also get a kind of bool true, tick false. So this, if we look at the very first one, that's a type constructor bool of the kind type. Because we played around with everything becomes a type, you know, so that's what it's saying. And then the true is of the type bool. So that's just normal. That's what we, you know, we'd say true is of the type bool. You know, so when we see a function not, we see the type definition bool to bool. So this is saying, well, true is of the type bool and false is of the type bool. Okay, but then with X data kinds, then you create this new thing that comes on scope. So you know, like the Haskell compiler will do it for you. It's not, as I found out in the other stream, you can't actually write this out. It's just there. Yeah, that created a bit of confusion. so you can't write that out. But in scope, you get these, which is like, so you get a new kind of bool. Okay, so that becomes a kind bool, and then you get a promoted data constructor. Well remembered, Helverson, or well known, and then you get from that shows you that it's a tick true, which is of the kind bool. So that's just, you know, it refers back to this, and then the same with false. And in doing that, you essentially the idea of it is you get the same functionality as those, but at a type level. You know, so what does this mean? So we can create a type family, and we can literally mimic like this OR. You know, so if we know that OR does bool to bool, so if true and whatever is going to be returned true, and then false and whatever is going to return that. But we can do exactly the same functionality, but at a type level. So this is the functionality that exists, yeah, at a type level. We'll be able to use these things at a type level, which is like, what are you on about? It's like an extra depth, isn't it? It's like, oh my god, just if you know, you thought Haskell was like magical already, you can do all this magic at a type level, which is, yeah, super impressive, I think. Let me just have a sip. And then in its definition, so we just create a type family called OR. Its first value is X, and we say that that's of the type bool, of the kind, sorry, bool. And Y again, and then the result of all those, so like, you know, if we see the arrow, that actually is bool too. Okay, so you have to give these two the type of bool. If you didn't, and you thought, well, okay, well, actually, isn't it just this? You know, you think, well, that's actually a type. But then what that actually creates is a type to bool to bool to bool to bool. So yeah, that's one just to remember. You can do it like that, and then in that case, you do exactly the same. You know, you pattern match on a, well, it's not pattern match, but yeah, you do the family. So you have an OR, and then at this point, because you're using kinds, so if it's of the kind, sorry, of the data promoted data constructor, I'm definitely not going to remember that. So if it's of that and it's Y, then just return true, exactly the same. And if it's of false and Y, then return Y. Okay, and we know that Y is of the kind bool, blah blah blah. And then with not, exactly the same. We know how not works. It's just one or the other. Yeah, and it just sort of demonstrated that. Did it show some examples? I think the example which sort of demonstrating was having an admin user. I couldn't 100% remember. And then the last bit that it showed was to do with something called symbol. So in the REPL, let's open up the REPL. Is it CR maybe? I've forgotten. No. Oh yeah, it's this. Here we go. We've got another thing available to us. Let's just press no a few times. Is that available? Yeah, cool. So we've got another thing called, so first and foremost we can set. So here I'm in like, it's just the same as doing in the terminal cabal space REPL. So that's all I'm doing, except it kind of pushes you along a little further. But anyway, and then we can do what is the kind, and yeah, so this showed us that you have I done it wrong? Oh, I haven't imported them. Haven't I? Oh no, let's have a look at something else. I think we came with this issue last time. Oh yeah, I'd need to import things. But anyway, the idea being that this, if you're doing kinds of a string of hello, it's a symbol. You'll see why this becomes useful later from memory. And we showed that we literally have the ability to do same as append with symbols. So, you know, look at the example. It just says do as Sandy and Sandy, and then that returns you EQ. Sorry, that's for compare. The append was here. So thinking with types, and then that should return you thinking with types. It doesn't act like a function, remember. This is all like at a type level. So if you just, what I did was I thought that this, oh, you just call this, and then that should result in that. But actually what you need to do is, where is it? That line here. Let's see if it works. I'm not going to spend too much time on this bit. Let's just do it like that. No, it's not going to work. I'd have to bring in a pen symbol. Okay, I'm not going to do that. But yeah, that's from the library types, is it? Where is it? I can't remember where it comes in. Yeah, GHC type lit. Literals. And then we went through numbers. Blah, blah, blah. Yeah, best off going to the other one. I'm more so doing this to remind myself, to be honest. I know it was a few days ago, but... Right, okay. So, we're here now. Let's create a folder. And what we're going to call it char03, I guess. Chapter. And then we're definitely not going to call it a file like I just did. Well done. So we're going to create a... I press F, but it's D for directory. I press F for folder, but it's actually file. Anyway, 0, 3. Not 2, 3. Cool, that's created that. And then we'll create a file and we call it chapter 03, isn't it? And it's .hs. Cool. We'll open that up. We'll close this rubbish down. We'll create a module. It's char03.chapter03. Yeah, where? Cool. And then just paste some random stuff in. Yeah. Oh, actually, I need to do another thing. Need to go into Cabal. And we need to add this here. There it is. And then, yeah, we'll change that to... Oh, I'm on one today. Today? Every day probably is the truth of it all. Cool. Okay. Right. So technically, if I... let's just make an error. Okay, well, let's just reload that then. Oh, yeah, it's going to... Cool. Give us an error, and then we're happy. At least then we know we've got an error. There we go. Okay. Yeah, you're putting stuff. Whatever. It's a good error. Okay. Right. So consider the following type declaration. Which of them have viable functor instances? Okay. Let's do it. Oh no, that's a bit annoying, isn't it? Okay. We have to like work out. This isn't too bad. We have to work out if any of these have functor instances. So if we were to do instance functor, and then it's just, I guess it just. No, I don't even need anything, do I? T1? Where? So look what that says. I mean, it's certainly not complained right yet. Yeah, you see how I keep having to sort of like reload the Haskell language server. I'm not sure why that is. But yeah, so here we go. But this gives us a good clue. So it's saying, don't look at it. It's saying nothing, it seems, what it does. No explicit implementation for, and it'll be fmap. There we go, fmap. Cool. So it's saying in our instance that we're going to create, we need to do an implementation for fmap. And fmap is an f of this t1. Something like that. And then we'll use type holes, good old type holes. And then it just won't work. So we'll have to do that again. Yeah, I don't know why that is. It just feels like, I mean, normally it's meant to do it on the fly, but yeah, I'm not sure why it's not doing it. Okay, so we want it to return a T1B is our return. So let's see if we've got anything going to B. So we've got an F that goes A to B, and then we've got an A that goes, where's that A? Oh, it goes int to A. So we need to, can we get to it? I don't think we can do that because we don't have an int, maybe? I think that's what it is from memory. I don't think we can do that one. Let's try it. So F, and then we know F takes 2 values. And then let's have a look at the first value. Let's have a look, because our F is meant to, no, so it's not even going to be an F. So here it'd be a, it'd be T1 of something, of F or something, wouldn't it? Yeah, there we go. That feels better. And F, what's our first error? Is it saying it's not happy? I'm pretty sure all these errors are happening for that immediate reason, because we can't do this. I think we can do things that go from A to int, but not from int to A. So I'm going to say that one we can't do. Yeah, that's what I'm going to say. The real explanation, that's my explanation as to why it doesn't work. Is that the right one? I'm not 100%. Let's do another one. Yeah, I was going to say, I did say, I'll put it on Slack. I'm going to potentially struggle with this, but that's what learning is, isn't it? So we're going to do T2, and I think this one's going to be happy. But if anything, this is going to show a good use of F is A to B. Hey, Sue PP. In there, yeah, F is A to B. As part of functor, yeah. So when we look at functor, that's what's happening. So I think because it's A to B, we need int to A, unless we call. I'm going to try this one, and then I'm going to see if my memory serves me right. Because I think this one can do it from me. Oh yeah, hi. Let me. What was I doing? I forgot. Yeah. This goes on about covariance basically, and that's where I got stuck last time. Hey, Alex, how's it going? I'm sure we were saying something funny yesterday, but I forgot what it was. So basically, can't have been that funny, can it? Which means we need to look at a positive and negative position when it comes to functions. Yeah, well, you're going to definitely. I'm glad you're here, Alex. It's a good thing you're here. Because these ones have thrown me a bit. But I think I can get through these ones. So I'll try this at least. You know, let's not give up straight away. I don't think you can do the first one, but I think you can do this one. Or it's the other way around. So we'll soon find out, won't we? So we've got F, and then we have a T2 of an A, don't we? And then what do we want? So this surely is going to tell us it wants to return a T2 of B. Something like that, I'd imagine. Or it's just going to be happy. Yeah, or I'm just going to put an equal randomly around. What have I done? What have I done? I've just done some crazy madness. Yeah. Where? Just out of the blue there. I would guess int A is in a positive position. Oh, is that as much as you know? That's no good. I think so. I think it does explain it later, but I'm gonna give it a go, and then we'll find out about the positive and negatives. What are the functor laws? Associativity and stuff. I don't know. This is my problem. I'm just like it's almost like I code by feeling. I'm like, I feel this is right, and then but in my brain it probably knows exactly what the issue is, but what comes out is feeling. You forgot too. Oh, so the question is, hold on. The question is, can you convert the A to a B? Yeah, that's basically it, isn't it? We should copy paste the laws here. Oh, okay. Shall we do it? Associativity and left and right identity. There we go. Everyone's on it. It's what I like. I'm still going to try and set up a job where everyone's here and they're going to help me. Let's do it. Okay, let's find it. So should we do functor laws? Should we look for that? I think we had it in the other. I think we looked at it yesterday. To be last time we did this, Haskell. I think they were here somewhere. Yeah, I know. L7 R7's on fire. I guess that's what they are, but does it give us proof of functor laws? Oh, I feel scared of this one. It's got the word proof. Oh. Here they are, though. That's it, isn't it? Right here. I assume. Hold on, let me zoom in so you can see it as well. Associativity, left and right identity. So that's our identity, and this is our associativity, isn't it? I think that's right. Let's bring them in, and then we'll see if we can. Where should we put it? Should we put it here? No, let's put it underneath. Cool. So there we go. So here we know we want a T2. We've got. Here we go. This is where it seems more feasible. We've got an F that goes A to B, and then we've got an A that's an A to int. Oh no, maybe it's the other way around. Maybe we can do this one. Maybe it's like something like that. Oh, here we go. SuPP. You might also want to use the instance SIGs language extension so you can write the type of the method specialized. Oh, hello. Yes, I think this is what it actually. I think that's what it goes on to. Let's have a look. Let's cheat and go a bit further down. Maybe it doesn't. But it doesn't mention it. You know. So and normally, Sandy does mention when things need to be added. So that's a good idea. But I think I'm gonna. Shall we follow? I'm gonna follow the book because I'm confused as it is, and if I don't, then I feel like I'm going out of comfort zone. But I've got a feeling that maybe that's right. Oh, I can't remember. Oh, this is when I'll just like go. Okay, that's worked. Has it? No, it's can't have worked. Don't say that's worked. Oh, you love adding type SIGs. I'm glad you. Hold on, that's worked. Okay, so you can go. Ignore. You know what I'm saying? Like, you know, I code with like sort of feely. You know, I sort of feel my way through coding. Clearly not. I'm rubbish. So you can do it because I've done I've done compose. That's kind of saying I'm waiting for something to come in, which was our A, and then our A is int to A, and then we can pass that to our F, which is then A to B, which then returns us our B. Yeah, because all of these are, as you can see, they're to do with functions, aren't they? So I was totally wrong. You can't do that, and it's the other way you can't do it. Let's split things up a little bit. Yeah, that'll do. Okay, so I think that's right, and I think this is the way you can't go. So if we could do a bit of that, and ideally here. So now we want a B to int, and if we look at our types, the only way we can get a B is to use an A, but we've only got a function that goes A to int. So if we do the same, it won't work. Yeah, that's. I think that's right. Did it say T1 is a functor? It just says. Well, no, it just asks which one of these have viable functor instances. So basically, which of these are functors? Give instances for the ones that are. So we have to guess. So yeah. Okay. SuPP, thank you. But I guess it is because it's just worked. I'm just going by the types. The type told me it's right. Okay. So surely, isn't that what they say in Haskell? If you know, oh, I'm going to move my camera back. It does mean you see more of my lack of hair, but I'm not ashamed. It's fine. But then I think that's got to do with what what's the type of f in T1 over here. That's a to b. Can we see it? Look up here. F is a to b because it's a functor, isn't it? Yeah, there we go. You've got it. That's right. So you know, you're still going to get the same stuff as a functor. So that's going to be a to b. Sorry, f is going to be a to b. This would be what's surrounded with f? Is it f of a? Yeah. Yeah, does that make sense? So it's basically... actually, look, let's just do it like this. It'll break for a moment, but let's just call it fa. Let's just put an underscore. Okay, and then if we look at what that one would be, t1 of a. Okay, well, we need to... Oh, that's not helping us at all. Yeah, but it's what it's surrounded in is a t1. So then we want to get into the t1 value when we do an f map. So that's why we then go, okay, well, I want to get inside the t1. So I reckon that what's inside of there is useful. And then when we get into t1, so if we look at our type, what's our a, or sorry, what's inside t1, sometimes it's good, sometimes it's bad, this documentation thing, is a function that takes an int and returns us an a. So we know that that's exactly what a is. That's a function that expects an int and returns us an a. And here, that's the function it wants. And but why I did... So that wouldn't work because you're just trying to apply a function to another function. But I'm going to read that comment. Hold on 1 second. But if you do compose allows you to say, well, you know, it's like creating a lambda waiting for the a to take that value. And once it's got that value, return it, put it into the f. So basically, we're returning another function that inside of t1, which is a b. That becomes b. Yeah, in essence. So let me read this to Sue PB. And what you said about T2 is also true. You can't change a function in T2 to b to int because you have a function a to int. You could do it if you had a function from b to a, but you don't. Yeah, because of that type constraint, isn't there? Because of this int. That's kind of like what throws it, I think. Yeah, look. But... Oh no, especially when you don't spell it right. Defined with an E. Oh my goodness. See, it works. Compiles. Ship it. Okay, so that's not one. So my other guess would be then that the other one that would work would be T4. Because if we look at the other ones, maybe T3. No, because that just does A to A. Can you get a functor of that? Probably not. T5. Yeah, I'm with you. Helverson, I think T5 is a good one. If we're looking at this a to int scenario, I think that's a good one. T4, no. T3, not sure. Should we try T3? Because a to a, I've got a feeling no, but we could be totally wrong. So let's try it. Whoops. Okay, so we've got a. Okay, so that's our type. And then we'll create an instance of functor. Yeah, this is why type holes are so good. Because, I mean, before I didn't really sort of do much of this. But I'm so reliant on them now. Now I know, and especially, yeah, they're just so good. What am I doing? T3. And then we'd get a value. We'll call it A. Okay. And then here it's going to tell us what it needs to return. So it needs to be a T3 of B. Yeah, we've got no way of getting an B, sorry, because if we look, the A just does A to A. So how can it return us a B? It's not, you know, it's not changing anything. So we've got no way of doing that. So that's a no-no. So we know that, and then our guess is that T5 should be cool. That was the one, wasn't it? So what was it? T5A equals what was it? T5, and then we're gonna have a bunch of these. Where are we? I should have just copied it and been lazy. I'm gonna type it out. T5 and then to int. Yep. So that's our type. And then let's have a look if we can make an instance for it. T5 where? Okay, so that's f map f, and let's do T5 Oh, what would this be though? Because that's like... okay, I'm going to just do a for now. This one's going to... and definitely do a plus instead of anything else. Okay, and then press the wrong key, and then press the right key, and then just press random keys until something happens. There we go. Got the right random key. Well done. Next, come on. A good way to figure it out is to... Alright, I'm reading what Sue PP saying. So a good way to figure out is to use examples and actual functions. Like A could be a bool and use show or something as the F. Oh, I see what you mean. Yeah. Oh, to actually try it out. Yeah, I think this is what sometimes sort of throws me. Which would be cool is I get to... Well, it's one of my pet peeves also when I was learning is like you go through Hoogle or whatever, and a lot of stuff is just it's just types. And I'm always like, oh, so what? Easy one, cycle. I was just like, let's have a look. This was one we did yesterday. It's like, yes, it wasn't like mega. Let's have a look. Look, it was yesterday because this is still zoomed in. So you get cycle, and then you wait for it to take you there. Ties a finite list into a circular one, or equivalently, the infinite repetition of the original list. It is the identity on infinite lists. So I was just like, okay, I think that makes sense. But really, it could have had a nice example going, cycle, I don't know, 1, 2, 3, like that, equals 1, 2, 3, 1, 2, 3, and on. That's basically what it does. There you go. I didn't get that from the description. So yeah, it's one of my pet peeves. And it kind of makes it harder to when you're learning, doesn't it, I guess? Especially when you write T5 with a lowercase t. That's always going to help out. Anyway, in stuff. So yeah, I'll carry on with this, and then yeah, maybe we'll write some functions out of it. I think it gets you to do that, though, to be honest. So we'll carry on and we'll try and work this out. I'll refresh, which it keeps asking me to do. Well, it doesn't ask me, I tell it. So let's look at our types. So somehow we're expecting an A. So we've got an A that takes an integer. Oh, this is going to be confusing. How are we going to get access to that? So I've got to say that one. Okay, so first thing first, we know this. So we're one step closer. Oh no, okay, the hole's not too bad. I got confused. The hole's actually, look, so it wants a B of int to int. Okay, so it's going to be exactly the same thing, you'd think. No, it's not. Oh, I was optimistic, wasn't I? Now what? It wants an A. No. Okay, I'm doing something wrong. Let's do hole again. T5B. Okay, so let's do T5. And then we'll do that. And then it wants a function that does B to int, and we've got A to int, and we've got a function that does A to B. So is it the other way around? No. What's it giving us now? But that can't... Technically I've done it. But yeah, I'm not using F, so bad times. How there? That can't have. That must fail, because that's just returning us an A of int to int. Yeah, that's fine. Yeah, that makes more sense. Maybe we stick something in here. There we go. So whoa. I thought it was. What is it? I think A is a function taking 2 arguments. Oh, does it? Oh, yes, it does. So, do we have to create... It is correct. Oh, because we do... oh, so you think... No. That's not right. It isn't. Okay. Yeah, I thought it wasn't. It wouldn't make sense if it was. I mean, it type checks, but yeah, I tried AF, but then it's yeah, I tried that, but then we get the type error. The A, so I think it's still the other way around. Do we need to do like hold on, are we just being a bit silly? Let's have a look. I've got a note. So it wants A there. No, well first it's not going to happy with that. Is it just another F map? No. I was being like very hopeful then, wasn't I? Okay, let's look at our types here. Look at the types again. Let's jot them down. So we want that function to be that. Okay. In scope we have. It's not going to show us. In scope we have A, which is we have A, which is that. So let's do an equal. Sorry, I'm speaking in front. I'm leaning forward. It's how much concentration you're getting from me today. And then we've got F, which was, we don't know anymore, here, which was A to B. Okay. And then we've got F. Oh, hold on here. So PP. We need to figure out how to convert. Yeah, that's the one. Yeah. That's what I've figured. So I'm just trying to write down F to A. Okay. No. What have I done? Is it? It's A to B. Silly. So basically we need this to be there, to go into there. But how do we get something like that into here? That's the problem I'm facing. That is the problem. But if we look at it, it's the lambda that's expecting an A. Yeah, that's a confusing one, this one. How do we make that? What types? What types would do this? Oh, it's going to be something dead easy, I reckon, as well. Come on, think. Okay, so what if we do an F of something? Now we want an A. Oh, this is where we're going to do... this has got to be to do with contramap, hasn't it? Because we want to do things backwards? I think that's what it is. I'm pretty sure. What I'll do, because I'm a dirty cheat... Where was it? Yeah. Oh, yep. Okay. What chapter are we on? 3. These weren't done before. I'm not cheating. Hold on. Where are we here? Maybe I can't. Oh my goodness. Okay. Ah, we could have worked that out. Oh, I'm a bit gutted now. I wish I would have kept going. I was going to say it probably needs to be a lambda. Okay, I'm not going to look at it. I've kind of remembered it. We know there's a lambda here. Okay, so we can do that. Okay. And we'll put another hole here. Okay, so technically we haven't cheated at all. You didn't see that. When it goes on YouTube, I'm going to cut that bit out. And then everyone will think I'm dead intelligent. Basically. Dirty cheat. So, oh, you're not helping me. What do you mean you're any? Why are you any? I don't want you to be any. Oh, I feel like I need to cheat again. I forgot what it was. Okay. I'm going to keep going. Let's keep going. So I think here we need to do something of A. Oh yeah, of course it's any because it doesn't know quite yet. What the heck is ID language? Hey, James Harris. What the heck is it? Have a guess. I mean, the big telltale sign's probably in the description, but you keep guessing. Let me know what you think it is. It's like, yeah, what the heck is that language? I like it. Haskell, hey, we got it. Unfortunately, if you've not done Haskell, this is definitely not the right stream. I do other streams for teaching Haskell. This is like a little bit more advanced. You've never seen that syntax in my life. Is it beautiful or not? Let me know. What do you think? I don't know why I've asked you that question, but you're going to have to answer me now. I'm trying to work out some madness. Yeah, this is like the worst one to get. I'm confused about this stream. So if you've never done it before, I feel for you, James. But what you can do, look at me, I'm going to plug myself. I've got something here. Was it your channel? Your videos? No, somewhere up here, isn't it? Your channel. There we go. I've got a channel. I've got a playlist. And I've got this one. No, go back. I've got view full playlist. Here we go. That one for you. And then that takes you from like the get-go, from going and not knowing any Haskell to just this level. No, it doesn't really. But it gives you a good introduction into all the magical stuff it can do. Yeah. Oh, is it confusing? Oh, hold on. So, Soupy, it's a very specific and convoluted exercise, though. Don't worry if it doesn't make sense. Okay. Yeah. Well, yeah, keep going. If you come from C, oh my goodness. Yeah, you've got your work cut out. If you come from C. Maybe you don't, though. Go check out the other videos I just linked. They might help you. And then you might find, well, this is what happened to me. I was JavaScript. I was like, yeah, JavaScript, fine. Because I kind of enjoyed the instant feedback, I think, was the favorite thing about JavaScript. And then I discovered a library called RxJS, which deals with streams and continuous streaming. And then the notion of that then led on to things like mapping and doing other little functional things. I was like, this is interesting. And then I saw someone mention PureScript. And I was like, oh, okay, I'll check this out. And then I kind of discovered types, and yeah, and then now I can't bloody go back. I'm stuck in a catch-22, where really, right now, I'm like, I've unfortunately got made redundant a couple months ago. And I should really just, take it and go back and do some JavaScript where I'll be able to just, get a job straight away. Not like so get big head or anything, but I've got good experience in it. Whoa! Did a sound come through for you for that? Let me know. But that's my new animation. I made it. But thanks for following as well, James Harris. Honestly, there's more to this channel than you think. No sound. Fuck. Thanks, James. Yeah, I did it on Procreate on the iPad. It took me friggin' ages. And this one, get ready. Sorry, I'm sidetracking. I always do this. I do coding, and then my little animations become the center. I know, no sound. What about this one? This one's definitely got no sound. But that's meant to be me. This is me right now, trying to work out this type. You see me? There I am. Procreate. It's wonderful. It's a good little it's a good little thing. It's good fun. Yeah. So this is Haskell, but it's going to be, unfortunately, this is going to be a little bit hard for you. Thanks. Oh, thanks. Visuals all around. Pats on my back again. Well, Vince, if you can't get it from nowhere, you got to give it to yourself, haven't you? That's the way I do it. Okay, so we're gonna cheat. I've decided. Because I felt like I could do it, and then I couldn't. A-I-I. Oh, hold on. I wasn't that far. I tried to put the F on the external bit. Oh. That's fine. I should have just followed the types. Stop being a big weenie. And definitely do whatever just happened there. There. Okay. Well, I think I remembered it now. Now I've seen it. No, I didn't. Yeah, well, I know we did that. And we did some stuff in here. Did I? Oh, I've got such a short-term memory. It's unbelievable. Maybe that's why I've been struggling learning Haskell. So if anyone's here and thinks you need to be a genius to do Haskell, you don't. You just sort of need a lot of determination. If you're happy with your job, learn write in C. Don't learn Haskell. You'll hate your job. Yeah, that's what I was saying. Yeah. I mean, any language is cool. You know, I'm not one of them. You know, if it's not a purely typed functional language, you suck. Like, not at all. You can do any. You know, it's always the language is right, the right language for the right job. And Haskell certainly isn't right at absolutely everything. No language is, but Haskell is really cool in the fact that you can do stuff like this. We're at the minute, it won't make much sense, but we're doing like type level stuff. So yeah. Yeah, Elm, that's a good... I unfortunately went from JavaScript straight into PureScript, but a lot of people did JavaScript, Elm, and then went into PureScript once Elm became a little too constrained in what you could do. Okay, so back to it. I'm going to cheat again. Just this time, just copy it, Vince. Don't. Just move on, okay? What I'll do is I'll copy it and then I'll explain it, because I'm pretty sure... Or we'll just go through the types. I don't know what I've just copied, so I'm just going to press... Whoa, I've definitely not... Okay, that's fine. Yeah, that's fine, that's fine. So, what have I copied? I've copied this. Okay, here we go. I don't want this random crap. We do want this. Okay, let's have a look at what types of things are. So we know here, this is going to be to do with contravariants, I'm pretty sure, which is what this is coming to. So we know that T5 at this point, let's just do a bit of magic. We wanted that function. So to return a function, obviously, the only way to do that is for it to be a lambda. It's going to give us a weird error for no reason. Okay, come on in. Come on in. Oh, well, we know... Oh, no, we don't. Yeah, we do. Why are you not happy there? Okay, well, I'll align it then. Is it to do with that? Yeah, literally. Okay, that's a weird one. Right, so if we look, we need a function that takes a... Well, yeah, it's a function takes a value that has a function that takes a value. Okay. So to do that, we clearly need it to be a lambda. Okay, so let's... what are we calling it? II. Okay, and then at this point, so we're inside that lambda now. So we're returning a function that's going to be expecting a value. What do we have in scope now? Now we want this to be int. Oh, okay. That makes sense. And let's have a look at what we've got in scopes. We've got II. There we go. We can get an int. So B to int. And we've got AII. Okay, which is that. So this is where we do... So that expects a function. So we need to make a function to pass to AII. Would be my guess. Not that I'm looking at the code underneath or anything. But I'm doing it like if we were... Oh, does it make your head spin as well? That's good. I'm glad to know. My head's spinning. Okay. But we're using type holes. So this is... Hey, if you're still here, James Harris, you know, you get this niceties in Haskell, which you might not get in C. We get a type hole. Our compiler kind of tells us what's in scope, all of their types, and potentially what it needs to be filled with to... for us to succeed in life. Now we need a hole of A to int. Have you succeeded yet? That emoji tells me that you're definitely succeeding. Okay, so we need something... All you end up doing, essentially, actually, because what we're doing is we look down here, okay, this is our results of... If I move it up a bit. Obviously, it's quite zoomed in, so, you know, I'm a bit squashed. But ignoring that, we get to know, so look, II, captain, is of B to int. Okay, so int in Haskell is an integer and B is whatever. And then we've got AII, and that's A to int and N to int. Oh, I can't explain any of this. It's just too, sorry, it's a little bit too advanced. it's just going to throw you. Just keep watching if you want, because I talk a load of crap. But the other ones would the other ones would be a good start, because they're really good actually, and you can follow along. There's a really good, an easy way to get started. Is it learn for Haskell? There it is. Yeah, this repo. Yeah, check this out. That's what my other videos are. It's just I'm just going through this repository, and then people joining along, and then we're just going through all the different chapters. I think I'm now on chapter 3, so I go quite extensively. I go really, like, you know, look, I'll show you. So I've spent, like, I don't know, 4 hours just on one chapter, and it's not, you know, it's not that much, but I just go really in depth. So if you're starting out, that would be definitely a nicer port of call than type level programming. Like, for sure. Yeah, I'd recommend that. But yeah, but here's cool, because it's got all the instructions, how to get things set up, and it's actually dead quick. You can do it on any machine. So yeah, that would be my advice. But you know, feel free to stay and watch me struggle. And you didn't answer my question. Is the type, does it look beautiful? That's what we want to know. You never answered that. I'm disappointed. Okay, so we've got A to int. Oh, how'd it go? Helverson. Sadly, have to go. Really enjoyed the series about the type level program. Thanks. No worries. Well, I'm going to I'll put the rest of it up on YouTube, and I'll keep going. But yeah, see you later, Helverson. Okay. What was I doing? Well, actually, you could probably, well, he's gone probably now, but you could also watch it on Twitch for a couple of days, however long it keeps it. I don't know. It does give you the option to just transfer a video straight from Twitch to YouTube, but the problem with that is it, you know, like I have like a 5-minute interval of it waiting for people to sort of arrive, and then it starts. Well, it keeps that, and then if you try and edit it inside YouTube, it's like an absolute pain in the arse, and it takes ages. So I have to download a video that Twitch creates, and then have to edit all those bits out and then re-upload it to Facebook. Committed to the cause, that's what I am. Forgot what we're doing, so we're going to do this. Definitely don't do what I'm just about to do. Yeah, that's right. But I'd like to actually, no, I don't want to fully do that yet. So we know, okay, so what was I just wanted to look and go over these bits just to double check how we actually, because this is going to be to do with contravariance, it's probably a good stead to get onto what's happening here. Can you rename it to BL? BI, which one? This one? II to BI. Is that what you mean? I'm going to count 10, 9, 8, 7, 6, 5. II to BI. Actually, I don't need you to say anything. Because, yeah. BI for bi-directional, maybe? I'm guessing. So B to int is what we need. Oh, look, there's a B to int. Okay, so let's look. So that's a function that takes B to int. And then our F returns us A to B. Yeah, cool. So that's why we compose F into another function, okay, that takes B to int. So look, B to int. So then we'd get a result of int. And then that, we'd pass that on to this. Oh, which, this is our function. Yeah, there we go. So here we've got a function from B to int. Yeah, there we go. And then that expects a function from A to int, but we're going to convert it with the F to a B. Yeah, because the whole thing needs to return the B to int, which is there. There it is. And that's how we get into it. Okay. Oh, yeah. A little bit confusing. Not too bad. Once you look and cheat. So, is it another advert? Go buy this book. Been doing adverts. B to int and A to int, maybe. Oh, what? Actually, fully rename them? B to int and A to... Oh, hold on. A to int, maybe. Oh, did I say it wrong? B to int, and I don't know. Yeah, I probably said it wrong. I think that's what you're saying, supp, I think. I don't know. I'm guessing. There it is. Look, covariance. Contravariance. Here we go. Okay. Despite all these similarities, well, we've worked out that it was 5 and I'm fine. Okay, thanks. Honestly, inside I'm not. I look at it, you know, I promote confidence. But inside I'm going, what the shit am I doing? But I'm going to do it. That's how you do it. Cool. So we've got to this part, and now we're going to do some reading. Like before, I enjoyed the what do you call it? Doing the coding, but now I'm like, oh, I need a break. Give me some reading. So despite all of their similarities, only T1 and T5. We didn't even look down, did we? Did we cheat? I didn't see that bit, but we got it right. Are functors. The reason behind this is one of the variants. If we can transform an A into a B, yeah, does that mean we can necessarily transform a TA into a TB? TA, TB, okay. So this is the answer. As it happens, we can sometimes do this, but it has a great deal to do with what T looks like. Yeah, so if we... Okay. Oh, not D8, just T. Okay. Oh, TATB. Okay. Depending on the shape of T, so if it's of the kind type, yeah, there are 3 possible T variants. Yeah, so that's of type, isn't it? If you remember when we were doing maybe and the other ones, because that's awaiting a type, or sorry, yeah, the kind of that is type to type. Yes, that's right. Actually, we can just prove that to ourselves real quick. Let's save it. Let's press that. Let's restart GHCI. Yeah, restart it. I don't mind. I'm just opening up the REPL. Remove. No, just keep them. I'm happy with it. Yeah, that's fine. And then it's reloaded it, and then it's just put it wherever. So I'll just do it like this. And then we want to find out. That was a wild one. Yeah. Which one was wild? The chapter, or my typing? That's pretty wild. What am I doing? Load. We're going to find chapter 3. Yes, we are. Let's do this. I wish... we can do it like this. Yeah, here we go. We'll move to that side. We'll do like that. Okay, there we go. Oh, I'm a bit squashed, aren't I? It's okay. It's fine. So I've loaded that, and I wanted to find out the kind of T5, didn't I? That was the idea. Q of T5. Yeah, that's fine. So we know that star to star is actually type to type. So that shows us our type of our kind, sorry, of T. In our case, it's T5. Yeah, because it's only expecting 1. So there are 3 possible T variants. So covariant, any function a to b can be lifted into an a function ta. Oh, pardon. Can be lifted into a function ta to tb. Okay. Contravariant, which I think was what T5 was. Any function a to b can be lifted into a function tb to ta. Yeah, this is right. It goes backwards, doesn't it? That's the the T5 functor instance. Yeah, that was a bit of a whoop. Definitely might not have done that without cheating. Though I kind of, yeah, I recalled it. I feel like it's a bit of magic, isn't it? Well, it's not magic. It makes sense if I can move this across, which I can't. Move across a little bit. What feature? Look, I don't know if it does it show up my little. Yeah, it's there. And it goes, look, you can drag me. So I go, okay. I drag, doesn't drag. Look, you can drag me. Okay. I drag, and then it drags. Whew. That was a moment in time, wasn't it? Well wasted. Yeah. I think that was the confusion, wasn't it? Because we were trying to get back that, and then we had a B available here, but how did we change that into a B? So the idea is when we do, T5 and this is what we want to return here. So we kind of had an inkling that we needed something to be a function. Okay, so we created a lambda. So I guess that there, if we look, yeah, that's right. So that then becomes this. So the bi becomes that part. Okay, so now we've got another function that expects a b to an int. Okay, so that's cool. And then we've got, I called them something different. That would be AII. AII. There we go. And then that's still f. Cool. So now at that point, we've got this. And then we need to, what was returning here? Yes, we need to return that. So then that takes another function. And that returns as an int. So at the end here needs to be int, doesn't it? That's the idea. Is it? I think so, yeah. And then this was the confusing bit, is where we get the f on the outside. So we say, here we say, because we're messing with functions, aren't we? That's the bit that's difficult. We're kind of like passing around functions. We're passing around partially applied functions. That's what kind of throws everything. So if we remembered from this one, it was understandable. You're like, okay, well, a, look, that's int to a. So we can just we can compose that with f. And then whenever we get the int, then we can pass that to the f, and the f expects an a. So we'll go, yeah, that's cool. But then in this scenario, it's a little bit more complex, isn't it? Because we're like inside a nested function, essentially. We're passing around. As here, we're passing around just a single function. Here, we're passing around a function that returns a result. So it's two functions. Yeah, I guess you could say it's nested. And that's where the confusion was. And then to get to the B, we had to partially apply. This was like the magic. Compose the F, which is what we use. And then from here, that always expects an A. So we go, okay, we can start from here. Then we'll compose that into BI, which takes the result, which is a B to an int. And then the AI expects this function here, which, can you see it if you'd like? We can if we do, hello, go away. If we do something like, let's do this, where poop equals, and then we'll see what the type of poop is. Cool. So poop is, I'd expect it to be a function, A to C, which is not, no, it's not going to give us the right function. And that's not, we're not going to access to that, but we will if we do it like this. If we do this. No, oh no, it's not going to work from there. No, it should do. Don't give up, Vince. Yeah, you're not expecting the value yet, but I'm going to give it to you. No, let's not just use random. Definitely do that, and that, and that. Cool, so now we can see what, we can have a better idea what poop is. There we go. Except, I've got an error. Yeah, I can't do it. I thought I couldn't do it. Okay, so let's read what SuPV is saying. I think the key point is in T5 is that we don't actually have a function a to int in T5. It is something to be supplied later. Not like in T2 where you already contain a function of a to int. We needed change. We needed to change. Yeah, that's what it is, isn't it? That's the bit that kind of like threw. So what? So yes. So we're dealing with a function that doesn't necessarily exist. And then here I figured I couldn't replace with poop. Oh yeah, look, it's fine. It's just, it's happy with it. Cool. So it is happy. And then let's have a look at again if it will show us the. I'll do this. No, you don't want to do that. Come on. No. Oh my god. Done too many things at once. Give it a type definition. No code actions. Why not? Okay. Well, we did see the code. Let's do it like this then. There we go. That's what the hole is. A function that takes a function from b to int and a and then returns an int. At that point. Yep. Okay. And that's what we're part. Yeah. I guess it's a little bit. And just spell it wrong twice. Let's move on. Let's come on. Keep going. Contravariance. So that's where it's the opposite way around, you see. We've got A to B and now we're doing A to B, but then we want B to A. Okay. And invariant, in general, functions A to B cannot be lifted into functions over TA. So I guess the other ones were invariant. Yeah, we couldn't do them because we were going the other way. Not the other way, just went a line or something. I'm missing a P. I'm missing a P. Oh, this is from before. Yeah, sorry. I'm always ahead of you. Literally. You have to predict what I'm going to do in the future. And then, yeah, you'll be good. Well, HS was faster, and the fact that I'm streaming ahead of you, I've got that advantage. So I've normally got, so if you type and then count how long it takes for it to show up on the screen, that'll give you an indication of the delay we've got, which I think is about 10 seconds, maybe a bit less. I don't know. Oh, another thing I was going to ask actually is the image, because yesterday's image I changed settings on how, because I found that I was streaming like really low quality, so I tried to bring it up, but I think the encoder was like making the image like twitch a bit every so often. So let me know if the image is doing that this time. Yeah, I don't know. I had no way of testing. So yeah, that sucked. The only way to test is to go live. And I think people... Yeah? Is it fine? Cool. That's okay. I guess if it's just a steady... You'd notice it. It was literally like... You know, sometimes you get like a little glitch. It was doing that with the colour a little bit. I forgot to ask right at the beginning. Yeah. And that was... I'm just... things like that just annoy me. You can see white flashes. No, don't say that now. It's a lie. Well, what I'll do is I'll check it out when I see it. Actually, I could literally just check it out now. I should have done that ages ago. Oh no, everyone's seeing it now. I shouldn't have mentioned anything. Now it's going to be you see it, you can't unsee it. So I've just shot myself in the foot. Shut myself up first. No, I don't. No, you're seeing something else. I'm watching myself in the past, and oh, this is funny. You can like do like that, and then wait a little bit, and then it like goes in. It goes into each window a little bit at a time. Right, stop this. No, it's not twitching. So what you're seeing is probably your monitor. Get a new monitor. Tin tin tong. Okay, let's go back to this. Look at me. I'm like trying to talk about everything but what I need to do. Oh, okay. So covariance is a sort we're most familiar with. Yes. That's so that we're, you know, that's like functor. So we can do covariant. That's fine. This is the one that we're potentially not. So it corresponds directly to functors. Yeah, there we go. Got something right. And in fact, the type of FMAP is exactly witness to this lifting motion A, B, TA, TB. Yeah, so we know that when we do functor, it's A to B, FA, FB, which whatever our structure happens to be, as long as it's a functor. But in this scenario, it's a T. Or it would be in T. T only worked on T1, T5. Yeah. Okay, so as type T is a functor, if and only if it is a covariant, okay. Oh no. A type A is a functor if and only if it is a covariant. Yes, it can only be a functor if it's a covariant. So it has to have the ability to do this. Okay. So before we get to when a type is before we get to when is a type covariant, let's first look at Contravariant and Invariance. Okay, I'm not going to click those because I clicked them last time and it took me all the way to the bottom. Don't do that. The Contravariant and the Invariant packages. Okay, so it takes you to the location of the packages. Both by Ed. Commit. Ed, bloody good job for confusing me. Thank you. But grand job, because I don't think I could have done it. Give us access to the Contravariant and Invariant classes. These classes are to their sorts of variance as functor is to covariance. Covariant. Oh, okay. So they're to deal with contravariance and invariance. Okay. A contravariant type allows you to map a function backwards across its type constructors. Yeah, this is exactly what we did. Because we had to do all that. It feels like it was backwards because we got the A and the B the other way around in the function, didn't we? Oh, okay. So I think it's kind of... I don't know where the one was. Up here. Okay, I'll imagine we were at the top and I totally ignored the one. Precisely speaking, variance is a property of the type in relation to one of its type constructors. Okay, because we have the convention that map-like functions transform the last type parameter, we can unambiguously say T is contravariant, as shorthand for TA is contravariant with respect to A. Okay, I think I get that. Well, I probably just don't. Let's move on quickly. Okay, let's do this. Class contravariant. I mean, we can... I'm going to write it out because apparently if you write things out, you're meant to remember them better. That's my hope anyway. Contravariant. I think this is where we get to see clearly the things going backwards. Yeah, so we get something called contramap. And that has a type of A to B. Miss out the B, as you do. Okay. And then FB to F A. Yeah, this is the backwards. Not S. G. To the end. FA. Yes. This is the one. So this is what we're going on about. If we look, when you do an F map, which might have somewhere else, but let's just do it. So F map is A, which is a I don't know, I've got to remember the words. Covariant. Okay, so it's like this. FA, FB. Yeah, that makes sense, doesn't it? Let's line them up. So we can see the difference straight away, can't we? These two are swapped around. And I think from memory it explains as to why this might be. I think I know the answer, but I'm going to read because I don't want to give my inaccurate answer. On the other hand, an invariant type T allows you to map from a TB to from A to B. Hold on a second. So an invariant type allows you to map from A to B if and only if A and B are isomorphic. Oh, okay. So they have to be isomorphic. In a very real sense, this isn't an interesting property. An isomorphism between A and B means they are already the same thing to begin with. Okay. Oh yeah. So hold on. Let's have a look at the type. A, B, B, A, F, A, F, B. Wow, look at this one. Invert map. Inv map. Okay. Oh, I don't know about this one. I'll have to... This will take some looking at, I reckon. Whoo. So, the variance of type TA... Variance. Is variance to do with... Yes. So, when we're talking about variance, it's these. Okay. With respect to its type variable, A is fully specified by whether A appears solely in a positive... Alex, you still here? If you're still here, they're going on about positives and negatives now. I say they. That's terrible. Sandy's going on about positive position and negative position. Okay, let's find out what this means. So the variance, I think it's basically lets you go back and forth between two representations of the same data. Yeah, that's the idea. And I think we did to and from in the last chapter. I think that was the one. There was definitely a to and from. Yeah. So this is... Okay. Oh, wow. Okay. Sorry, my head's thinking, and I'm trying to think out loud, but it's so busy thinking that it can't think out loud. I'm in a... Wow. Okay. Keep going, keep going. Don't let your brain distract you. Just read out. Okay, so let's read this again. The variance of type TA with respect to its type variable A, okay, that's that, is fully specified by whether A appears solely in a positive position or solely in a negative position or in the mix of both. So that being, because we were doing here in the positive or negative. So I guess that's positive and that's negative. Yeah, that makes sense, doesn't it? Is that, I think that's what it is, isn't it? So that's in the negative. Oh, okay. Well, don't listen to me. So I think functioning arguments are negative position and results are positive. Do I want to become famous? Oh, what? Yeah, but I'm going to delete you. Bye. Yeah, it's gone now. I've learned that I can't press the little clock because that times people out. But the bins definitely get rid of spam. I should have a spam filter, but you know, I don't get that many watchers, let's be honest. I can do it myself. Badly. Okay, let's go back to this. Oh, I want to get to write more codes because I'm lost a little bit. So we need to work out positive and negative. I don't know if you're right, to be honest. L7R7. I should know your actual name. I forgot what it is. I'm terrible. Everyone needs to have their like tag. Yeah. Oh, you're not sure either. That's good then. Makes two of us. We're winning. Let's keep it at that. I feel that maybe what I'm thinking is correct, because if you think about it, there's a big gap in the volume. It was talking about positive and negatives. We need Alex here. He's just sodded off and left us on our own, isn't he? Because he mentioned it before, didn't he? Negative and positive. But I'd say that maybe my intuition might be correct in the fact that when we looked at the type, it was where this... pretty sure I'd explain it in a few sentences. Yeah, I know. Oh, Leo, cool. Yeah, because I keep trying to say the numbers. Leo, okay, I'm going to remember that. I probably won't remember though. How can I remember? Okay, I'm going to vision L7R7 to be like a lion. Leo. So I'm going to envision... Yeah, okay, I'll try that. Yeah, I'll forget. What's the name again? So bad. Okay. Let's go back to this. Yes, I was saying something of knowledge, maybe. So that feels like it's in negative, and then that's in negative, and that's in positive. But who knows? Could be entirely wrong. Maybe it explains it. Come on, let's take it on. This might explain it to us. Negative position or in a mix of both. Type variables which appear exclusively in positive position are covariant. So if they appear in a positive, it's got to be positive. It's got to be, hasn't it? I think. Whoa. This was from the previous exercise. I like how it's formatted it to make loads of sense. Was that like a history of me trying to work it out? We're going to keep going. Yeah, it's a shame you can't get a formatter on Slack. Slack? Twitch? God knows where I am. Where was I? Come on, we can come on. I feel like I need a break. No, it's not that bad. Okay, so we've gone through this little bit. Type variables which appear exclusively in a positive position are covariants. Those exclusively in a negative position are contravariant. Well, hold on. It can't be this left. It can't be that, because if we think about it, yeah, I reckon you're potentially more right about the last one being positive, and negative is when it's inside of here, and then here would be positive. That feels more right, doesn't it? That feels like that'd be negative and this would be positive, whereas that's positive, and then that's negative. And then that would reflect, because we know that that's got to be some sort of a contra variant because of the stuff we had to do to it. Yet as this one is it covariant? Yes. A covariant because we didn't. I'm going to go with that for now, and then never correct myself and learn the wrong thing to infinity. Maybe it'll explain. Keep reading. Okay, so and type variables which find themselves in both become invariant. Yeah. So invariant, I guess, is if you were to have an A here and an A here. I guess that's the idea. Maybe. I don't know. Oh no. But isn't this what it's doing, an invariant there? I don't know. Okay, but what is positive? Oh, I mean, goodness gracious. Stop trying to think about it. It's going to tell us right here. Minus, hello Haskell, minus times minus, or is it equals plus? Oh, is that? Oh, I mean, honestly, my brain's fried already. Don't put things like that out there. It's going to make my life worse, simpler? I don't know. But this is going to explain it to us. It looks like. Hopefully that's not a question mark with no answer. Recall that all types have a canonical representation expressed as some combination of tuple, either, and that. Polymorphism. Yeah. We can therefore define positive and negative positions in terms of these fundamental building blocks and develop our intuition afterwards. I feel like this led me like on the route to misunderstanding, and then it was like, now you've struggled, here's the answer. Ha ha. No, I don't think it's probably me. I should have just read on. But I didn't. I was convinced to try and work it out before reading on. So let's do our intuition afterwards. I think that's what you're basically mentioning here, Haskell. I've got a feeling, because either A, B, so you've kind of, I don't know, the position A is a plus and B is plus. So that's positive, 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 okay? And then another here of a tuple AB, that's a plus and a plus. But, yeah, I think we were right, weren't we? It was the left-hand side or right-hand side. But A to B, the A then's a minus, that's in negative, and then there's in positive. Yeah, so that's a negative and the B's in positive. So if we look back at here, I guess that's in the negative position, whereas that's in the positive. And it's going to be a negative because it's also inside of here, which is on the negative side. Yeah, okay. Should we go? I think the intuition was fairly close. The part I was talking rubbish before, but we got there. Wasn't too bad. So the conclusion. Keep reading. Oh, okay. Okay. Just shut up. Keep going. The conclusion is clear. Our only means of introducing type variables in negative position is to put them on the left side of the arrow. Stop trying to work stuff out that you don't know. Read, I'll tell you, idiot. Oh well. I like struggling. Maybe, just keep going. Okay. I'm just convinced. Only means of introducing type variables in negative position is to put them on the left side of an arrow. There we go. That's all it was. This should correspond to intuition that the type of function goes backwards when we precompose with another function. Yeah, that's a bit that's like, whew. In the following example, precomposing with show. So we got bool to string transforms a type string to list of string into bool. Yeah, that makes sense. So when we compose these two, ultimately that's the type, isn't it? So we've got a bool that comes in, and if we look, we pass string into string of the input, this one, and we return list of string. Okay, and we can verify that by looking at some stuff. Let's do it. We can verify that by not looking at this stuff. There is, the shortcuts to make them larger and smaller are really crap, so I have to do it by hand. I like to think I can still do things by hand. I don't mind. Words, types of words is exactly that. Let's see. So that's a string to show. I'm sure you mentioned this, didn't you, before, Sue PP, saying maybe we should make some. Is that or Tintin Thong mentioning maybe we should do some. It was Sue PP, yeah. You mentioned maybe we should just make some things, some functions that show this. Okay, so we got that. The type of show, which I mean we should know, but we'll show it anyway. We'll show the type of show. Cool. So ultimately, string to list of string and then a to string. Okay, so we can pass show onto words. And then if we do types, words, here we go. And show, and we'll give it bool. Oh, okay, so it's just, yeah. So if we do words composed with show, and we say that show is going to deal with bool. This is just we're making that a concrete so we can see exactly what it becomes, which we're not going to see, basically. There it is, bool to string. That makes sense, doesn't it? Yeah. Cool. Mathematically, things are often called positive and negative if their signs follow the usual laws of multiplications, which is what you mentioned, it minus times minus equals plus. That is to say, a positive multiplied by a positive remains positive, and a negative multiplied by... I've lost. I was looking to the left and I came back. That's to say, a positive multiplied by a positive remains positive. A negative multiplied with a positive is negative, and so on. Yeah, negative makes positive. Okay, so there was... that was like just a... you just put that comment out there like, here you go. Bam, have some information. And I was just like, what's that? But it mentions it further down. Note to self, keep reading. Variants are no different. To illustrate, consider the type A, the tuple A and bool to int. The A in a subtype A to bool is in a positive position. But A bool, in a subtype. So here, it's in the positive. Yeah, that makes sense because it's like this, isn't it? If we go type of tuple. Oh no, we can't do it. But anyway, that's a function that expects two values, isn't it? So that would be on the right, which is bool. So hold on, CPP. The tuple is part of the bigger type that is the function. Yes. Okay. Okay, and okay, that makes sense. But A to bool is in negative position relative to... Oh, yes. Okay. So it's in a positive in reference to here, which makes sense, which is like what I was leaning towards. But when it's in this, because of the arrow, then it's inside the negative, so it's on the left. As we remember from earlier arithmetic school, no, definitely don't remember that. A positive times a negative is negative. So, okay. So it's in the negative times, so positive times negative, yeah, so that's positive times negative, that's its location, equals is negative. That's right, isn't it? I think that's what I'm saying. And so a bool int is contravariant with respect to a. Oh, yeah. Blimey. Okay. Right. Oh, it's just checking things weren't going off. Okay. Whew, whew. Okay. Keep going. Can do it. This relationship can be expressed with a... I hope they have a relationship and they make lovely... And they have, you know, well, yeah, they don't get divorced or anything like that. No, relationship doesn't involve marriage, does it? So, right, go on, get on with it. This relationship can be expressed with a simple table. But again, note that the mnemonic suggested by the name of positive and negative position should be enough to commit this table to memory. Okay, let's have a look then. A, B. So, okay. There we go. Hold on. Let's copy this table somewhere. Somehow. Yeah, not such a good table anymore, is it? It doesn't copy into little lines. Okay, so A and B, so I guess it's if they're both in positive, then when they're composed, that gives us a positive. Or is it the order that... yes. And then when A is positive and B is negative, that's a negative. Okay, well that makes sense. Let's look at it when it gives us the example. So T1 is like int to A. So we've got a T1. Yes. Int to A. Cool. So if we look at our A, it's in a positive. Yes. So just a positive equals positive. Cool. So we got that. Yes. And then T2 over here. And then the A here is there. So that's going to be in a negative. Yes. So negative equals negative. And then AA. Yeah. So that's... A is negative. A is positive. And that equals... Which is... Well, I guess that's the third one, isn't it? So that would equal invariant. Yep. Which I guess is what that symbol means. Does it tell you? No. It probably tells you if I read. So I'm going to keep reading. This one. Aha. This is where we have to do... yeah. Oh, God. This is so easy when you think about it. If you just look. Okay. So we know the things on the left are negative. Things on the right are positive. That's literally what it's doing. So then if we look at T4, this whole thing is a negative. Okay, that makes sense. And then in this scenario, the A is in positive. Okay, so it's negative times positive. Negative times positive is a negative. Okay, that makes sense. And then that's it. So negative times positive equals negative. Yeah, okay. We're catching on now, aren't we? And in this scenario, it's in a negative here, and then it's in a negative there. So it's negative times negative. I was doing composed, but really that's like times in maths, isn't it? Yeah. Okay. So it's on the left, negative. On the left again, negative. Negative times negative is a positive. And that's why we can do T5, but not... Go away. But not T3. Because if... First and foremost is... Yeah, so that's Contravariant. Is that what it's called? So that I'll try and remember it. I've got Covariant, Contravariant, Invariant, not Intravariant, Invariant. Yeah. Sweet. Okay. Okay, I'm happy with that. Happy I kept going, because it makes sense. So this analysis also shows us that T2 and T4 have contravariant. T2 and T4. Yes, they're contravariants because of the minuses. That makes sense. Negative. Let's say minus. Negative. Cool. In instances, and T3 has an invariant. Oh, well, we got T3 right. Yeah, because that's invariant, because they're exactly the same. So that. Cool. Okay. I'm happy now. It's like it's sinking in. A type variance also has a more concrete interpretation. Variables in a positive positions are produced or owned. Oh, okay. So variables in a positive position are produced or owned. So that's okay. So produced is like, because they're almost like created, aren't they? They're produced. So thinking about it like this, that A is produced from. Okay, hold on a second. Stop doing that. Go away. There we go. Yeah, it's my my documentation thing, which is really handy, but not when you've got everything cramped up like this. So int to A, our A is our, what was the word that used? Our owned or produced. I'll go with produced, because it looks like it produces an A. And in this scenario, it's not. In this scenario, well, whatever. And then, yes, that's when it's in a positive though, isn't it? But here, it's in a negative, and makes a positive. Okay, keep reading. Whilst those in negative position are consumed. No, that's fine. So produced and consumed. Yeah. That's essentially, it's just, left, right. Yeah. Some products, sums, and the right side of an arrow are all pieces of data that already exist and are produced. But the type on the left side of an arrow is indeed consumed. Yeah, so anything on the left is what we eat in, what we expect. It's the old Hoover. So we want that, and it'll produce that. So it'll consume an int to produce us an A. Okay, that's cool. Okay, there are some special names for types with multiple type variables. Oh, okay. A type that is covariant in two arguments, like either and tuple, is called a bifunctor. I've always heard of bifunctors, and then I've probably used them, but I've never outrightly go, okay, this is a bifunctor. Right, so either and a tuple are bifunctors, because there's a covariant in two arguments. Okay. A type that is contravariant in its first argument, but covariant in its second, like this, is known as a profunctor. What is the name of just the arrow? I don't actually know. I know it's like an isomorphism, but what does it actually have a name? I've totally forgotten. You know what? Well, look, it's just arrow. Yeah, do you reckon? Arrow. Feels like it should have a. I mean, come on, Haskell's so terse. You've got to have a name for arrow. No. I was being wishful, weren't I? But I'll find an arrow. Or just function. Yeah, I guess it's just. No, but I'm sure it's got a name for it. No, let's ignore it. My brain's not going to remember, let's be honest. Be truthful with yourself, Vince. Okay, is known as a profunctor. So, but covariance in its second. Okay, there are some special names for types with multiple type variables. A type that is covariant in two arguments, like either. So either A, B. Okay. Oh yes, they're both on the right. Yeah, is that in the? I guess that's what it means. And a tuple, yes, is called a bifunctor. A type that is contravariant in its first argument, but covariant in its second. Oh, that makes sense, because the first to be there and the second to be there, so left and right, is known as a profunctor. As you might imagine, edcommit has packages which provide both of the type classes, although bifunctor now exists in base. Ed, very clever. I guess he's a guy, isn't it, Ed? Yeah. Clever chap, isn't he? So positional analysis like this is a powerful tool. It's quick to eyeball. Yeah, once you get it, it's not too bad, is it? And lets you know at a glance which class instances you need to provide. Better yet, it's impressive as hell to anyone who doesn't know the trick. It is. I'm going to say it's pretty impressive, isn't it? Yeah, so once you see it like this, it makes sense. Contra Variant, Covariant. Hold on. I'm gonna try and make this so Covariant, Contravariant, Invariant. Okay. And then plus is. It is a great book, isn't it? Yeah. I think the thing is you have to keep going, don't you? Instead of like, when Sue PP was saying, just read on. He meant to put idiot at the end, but he didn't. Or it might be a she. Sorry, Sue PP. It might be a she. I'm just assuming here. Terrible of me. Yeah. You just got to kind of keep going and you get it. So, didn't you say that? Just read on. I thought you said just read on. I'm going to look up. Maybe it wasn't you. I can't be asked to find it. Basically, I'm allowed to speak and you can't. So I'm right, you're wrong. That's how my whole life should run. Just like, I can speak, I can say what I want. You can type, but I can delete it. So it never existed. So what I'm saying is real. A bit like Trump, aren't I? Oh, you didn't mean idiot. No, I added that in. Of course you didn't mean idiot. People are too polite. It's a bit harsh, isn't it? Oh, thanks for doing this video, idiot. Though, to be honest, I wouldn't take offence to it. Don't matter to me. Yeah, it's a shame. A lot of people that do things like this, unfortunately. I don't know. Maybe yeah. There's like the guys that were doing the Learn for Haskell. They got like a bit. They were trying to do the advent calendar for Haskell, and then some person, I don't know, just moaning about. I'm going to read your comment in a minute. Sorry, Leo. Wow, yes, I'm so happy I remembered your name. Yeah, they got a hard time because apparently the website didn't suit someone's eyes, or not eyes. They didn't like the look of it or whatever. It's like, get lost. And then they got all bummed out because, you know, they tried so hard to make the website and then they just got grief. And it's just like, I guess the problem is if you're putting stuff out there, you have to have a certainty of thick skin. So like for me, if people don't like my videos, simply they can just fuck off. It's just like, it's not hard, you know. I don't care if you don't like it. Doesn't matter. I mean, I'm all up for constructive criticism. You should say, oh, you know, you could maybe like go a little bit slower, or, you know, try and explain things a little bit more, or do more animations because they're far more interested than your content. That's fine, but it comes to a certain limit where, you know, when you get straight out hate, and I'm technically just doing free content, you can do one. So I don't care what you think. But yeah, so that's don't know why that came about. There's a reason. I'm going to read your comment now, Leo. Remembered it. It kind of makes sense, but the part with variables in positive positions are produced is confusing when I look at T5 example. Let's have a look at T5 again then. Yeah, okay, I can explain that. Cheers. That kind of sucks though. I think about all of the awesome content we're losing because people need to have thick skin. Yeah, it is a shame. It is. It kind of sucks. And it comes also with people, you know, you watched it. That's why I kind of like limit. I've never owned a library in open source. And I think my main deterrent is I don't want to have to deal with, one, the upkeep, two, the wankers. You know, like people demanding like, oh, what do you mean? It's, and any time I like do any, because I like to contribute and I just contribute to others, but I'm always like mega polite, and then I'm not expecting an answer straight away, and you know, just things like that. It's just, I understand that they're doing it out of the kindness of their, you know, they're doing it in their spare time, or even if they're doing it for a company, whatever it might be, you know, it takes time and it's someone's effort, and unless you're paying them, then yeah, take your requests. Shove them where the sun don't shine. Right, we're going to go over T5 to explain this left and right. And the perfect example is right here. And it refers to this table. And it's basically, it's like basic, what they call it, like high school arithmetics. And we know that when we, and this is not the dot that we use in Haskell, it's times. So A times B. Yeah, so and the example that we gave way ago, so we do plus times plus is a plus, plus times minus is a minus, and so on. So when we look at T5, we take a look at this foremost, okay? So that splits it up. So that goes left and right, okay? So we know that if it was here, it'd be a plus, and if it's on this side, the whole chunk is a minus. So we know that's a minus. And then within that, we have to look at the left and right here again. And we know that's a plus and that's a minus. So we're actually left with two minuses. Okay. And then by that point, we're doing minus times minus. So that gives us a plus. It results as a plus. It's easier when you look at it in here because it's literally left or right. But I think once things start being inside of each other, then you times them. And then that creates that minus minus. What would happen if there's 3 there? I don't know, but we're going to go with 2 because that's what it deals with. So does that make sense? I think that's your question. Yeah, I think that's what you were asking. So that's where that comes around. And then if it's a it's not produced. Aha, let me reread your question. So variables in a positive position are produced. Oh yeah, I see what you mean. Yeah, you'd think that if they're, but it's a negative. No, hold on. T5, look at T5, not T4. Oh, I see what you mean. Yeah. Yeah, is the A produced? It's not. It's consumed. But then it becomes a produced. I don't know. Shall we read it again? This analysis also shows us that T2 and T4 have contravariant instances. Okay. Was it a bit further down? No. I guess it's got to be in this paragraph. A type variance also has a more concrete interpretation. Variables in a positive position are produced. Yeah, which this isn't. But I guess what it means is the result of it. It'll be like what? The result. But I see what you mean. Technically, at this point, it's still consumed. But if we look at T... maybe we do produce it because of the way this does. Hold on. I think it is because of the contra map, because it goes backwards. Except, oh yeah. Yeah, I think that's what it is. I think. We'll read on. Take the advice, read on. So, a type variance also has more concrete interpretations. Variables in a positive position are produced or owned, whilst those in a negative position are consumed. Products, sums, and the right side of the arrow are all pieces of data that already exist and are produced. Okay, but the types on the left side of the arrow are indeed consumed. There are some special names for types with multiple type variables. I think that's where because these have multiple type variables. A type that is covariant in 2 arguments, like either, is called a bifunctor. Now it goes on to something else, doesn't it? I don't know the answer to that. We'll have to ask. A type that is contravariant in its first argument, but covariant. Let's write the question down. I'll see if I can. I'll ask Sandy, see what he says. So we want to know why is T5 both on the left. that consumes its type variables. Yeah, I think that's. Well, I don't know. I'm going to ask. Why is T5? Where is it? Yes. So this we want. Basically, we want that. So why is that A both in the T5A both in consume and ultimately I've probably spelled wrong. Yeah. If I spelled that totally wrong. Ultimate telly. Who cares? Because of minus times minus equals positive, then it must be a producer or produce. Was it just produce? Produce. Consumer, produced or consumed. Yeah, produced. Then it must be produced. I'll be able to expand from that. I'm going to ask. I'll be back on the next stream and we'll explain it. We'll find out. To be honest, to me, it feels like the analogy with consuming and producing doesn't always hold. Yeah, I think it doesn't hold when you have things on the, like that scenario, because you got my streams at the same times every day. No. That's why I got a varied, viewers, because I just do it when I can be bothered, which can be every day or it can be. But generally, as a rule of thumb, I'd say in the week it's more likely UK time. It can be I'm like such a variant. Weekend, YOLO, whenever I want, basically, and weekdays it's usually like 4 p.m. onwards. It's the best, either before food or after food in the evening. That's basically what it is. And weekends, I don't know, whenever I get too bored, I guess, which is, today happened to be whenever I started. I think we got to the end, haven't we? So look, yeah, we have. Wicked. Okay, let's read the last little bit. Probably a good time to stop. Although Bifunctor now exists in base. Okay, positional analysis like this is a powerful tool. It's quick to eyeball. I already read this and lets you know at a glance which class instances you need to provide. Better yet, it's impressive as hell to anyone who doesn't know the trick. I think I'm going to remember it. I'd forgotten it, even though I'd already read this twice. I still forgotten it. But I've remembered another thing. Leo. Honestly, I'm on fire now. Don't want to stop now. I'm remembering, but I'm going to, because I think it's better if we can try and do a chapter per stream. We're probably like on a good road to going. Look, here we go. Chapter, part 2, lifting restrictions. We'll have a quick scope. Yeah, working with types. Yeah, this one's got a load more coding, I think. I get stuck on the next chapter, so that'd be fun. Yeah, I'm going to stop here. Why not? I think we had a good run. End on a high, don't you? That's what you do. That's what I do when I do when I still try and skateboard. And then if you learn a couple of tricks, you're like, I could stay here and try a load more, but I'll probably fail. So I'm gonna go home. End on a high.